There are many problems affecting our coastlines. People who live along coastlines are extremely vulnerable. First, there are many possible natural disasters which can only occur or are more likely to occur in coastlines, such as storms, flooding, erosion, tsunami, etc. Another huge factor is human activities. Humans' pollutions are affecting coastal ecosystems. Some forms of pollution are fertilizer runoff, oil spills, and dumping of hazardous materials into the ocean. Human development is one of the major problems when facing coastal hazards. Infrastructure, including the construction of buildings and houses on the coastline, takes away the natural currents to handle the fluctuation in water and sea level rise. Building houses on weaker coastlines can have a dramatic effect on that area. Having houses and buildings in areas that are known to have powerful storms will put the people living there at risk. More and more houses today are being taken by the ocean. Another major problem facing coastlines is their growing population. Over 40% of the world's population lives on the coast, and by 2025, three-quarters of the human population will be expected to live on the coast. This huge growing population is going to put a large amount of strain due to sheer weight and changing of landscape, which is caused by agriculture and infrastructure on the coastline, potentially leading to several problems. Activities orienting from this small land area will impose a large amount of pressure on the global system.
During 3500 BCE, the Romans were the first to build coastal management projects through breakwaters built by hand. These hard structures are powerful enough to stop waves, however, they are incredibly obtrusive to the operations of a harbor. Nonetheless, they were used until the 1950s. During the 20th century, a softer approach, known as beach nourishment, began to seek popularity. This process is known as replacing lost sediment and sand on the beach. Not only could this reduce storm damage and be more flexible in management and design, but it also helps provide a more economically viable opportunity. However, one disadvantage is the fact that the continuous erosion will be felt elsewhere.
So now I'm going to talk about some coastal management strategies. So the physical management of the coast attempts to control natural processes such as erosion and longshore drift. So there are two types of options: hard engineering and soft engineering. Hard engineering options tend to be expensive, short-term options. They may also have a high impact on the landscape or environment and be unsustainable. So there are three different types of hard engineering solutions I'm going to talk about today. So the first type of defense I'm going to talk about today is the building of a seawall, which is a wall built on the edge of a coastline. So the advantages to this is that it protects the base of the cliffs, land, and buildings against erosion, and it can prevent coastal flooding in some areas. The disadvantages of this is it is expensive to build. The curved seawalls reflect the energy of the waves back into the sea, and this means that the waves remain powerful. Over time, the wall may begin to erode, and the cost of maintenance is very high. So the next option I'm going to talk about is building groins. A groin is a wooden barrier built at the right angle to the beach, and it has a few advantages. The advantages are that it prevents the movement of beach material along the coast by longshore drift. It allows the buildup of a beach. Beaches are a natural defense against erosion and attraction for tourists. The disadvantages are that it can be seen as unattractive and it's costly to build and maintain. So the last option I'm going to talk about today is rock armor or boulder barriers, which are large boulders that are piled up on the beach. The advantages are that it absorbs the energy of waves, it allows the buildup of a beach, and some of the disadvantages are that it can be expensive to obtain and transport the boulders. Now I'm going to talk about some soft engineering options. Soft engineering options are less expensive than hard engineering options. They are usually more long-term and sustainable, with less impact on the environment. There are two main types of soft engineering. Beach management is the first. This replaces beach or cliff material that has been removed by erosion or longshore drift. The main advantage is that the beaches are a natural defense against erosion and coastal flooding. Beaches also attract tourists. It is a relatively inexpensive option, but it requires constant maintenance to replace the beach material as it is washed away. So the second option is managed retreat. Areas of the coast are allowed to erode and flood naturally. Usually this will be in areas considered to be of low value. Example, places that are not used for housing or farmland. The advantages are that it encourages development of beaches as a natural defense and salt marshes, important for the environment, and the cost is low. Managed retreat is a cheap option, but people will need to be compensated for the loss of buildings and farmland.
The Wirral is located in the northwest of England, to the south of Liverpool. The Wirral is a peninsula, meaning that 3 sides of the Wirral are surrounded by water while the fourth side is attached to land. The Wirral serves as an important port for the United Kingdom, and today sections of the Wirral coastline are used as reasonably popular tourist destinations. Different types of coastal defense mechanisms have been employed to attempt to reduce the impacts of coastal erosions on this coast. New Brighton is at particular risk of coastal flooding and erosion due to its location. Located on the northwest tip of Wirral, New Brighton receives a pounding from the sea. Waves that impact New Brighton are very strong. In addition, a low-pressure system around New Brighton means that storm surges are common occurrences, making the area particularly susceptible to flooding. This is worsened by the fact that most of New Brighton is only a few meters above sea level, so only a relatively small storm surge would be needed to flood a large section of New Brighton. In order to protect New Brighton, several sea defense mechanisms have been employed. In order to protect against both coastal erosion and flooding, a large seawall was constructed in the 1930s known as King's Parade Seawall. This wall is 4 meters tall and stretches along 2.3 kilometers of coastline. It was constructed using leftover material from the construction of the Kingsway Tunnel. The wall is specifically designed in order to reduce the impact of waves as much as possible and increase the lifespan at the same time. The top of the wall is curved slightly in order to reflect the waves back at impact. This helps reduce the rate at which the seawall is worn down, since it is slowly being worn away. This is one of the main issues with the wall. It requires a lot of attention and it is expensive.